Alright guys, welcome to the final video of your Unit 2 AAQ Chemistry. It is going to be a slightly long video and we are going to be looking at polymerization. So this is some more types of reactions that you need to be aware of and how to predict the products and the reactants and how to draw them. I'm not going to go too much into the theory. As you're aware, the theory is throughout the booklets, so you can read those, but let's just show you how this works first of all. So a polymer is this thing right here. It's a long chain of what we can see here is polychloroethene, so it's PCE. Most plastics that you guys are used to or aware of, they're going to be called polymers. And they're made from what we call monomers. So a monomer, are these guys. And these are the singular repeating units. So if I stick all of these together in a reaction we call polymerization, we make a long chain like this. And eventually that chain becomes so big, it becomes like a blob of plastic, and then we shape it into the chair you're sitting on, or the phone case, or whatever it is you've got in your hands. So I'm not interested too much in showing you guys the deeper inner process of like how that bond breaks and everything, but what I do want you to be able to do is to write equations when you're given a monomer and how to produce the polymer. Let me start you off by showing you this. So on page 131, you can see here writing equations, and I've got an example for you right now. Now, this is literally the answer that you need. And it'd be around 2 marks, sometimes 3 if it's quite a complicated monomer, but for the most part, it's about 2 marks. Now, in order for you to go from this to this, the process that I would use, I'm going to show you now. So we're going to have ethene, 2 carbons, and a double bond. And in order for it to be polymerized, it needs, in addition polymerization, it needs to have a double bond. So if you remember last time with the alkene we had last time, we had addition reactions and we're adding chlorine to it, we had hydrogen bromide to it, water to it. This time we're going to add itself to itself. The way we draw that is, let's say for example, I'm going to cover this up so it kind of makes it easier to explain. I know you guys can see it in your booklet, but if you're just looking at the screen, you can see here, this is essentially the question. So how do I draw polyethene from this? Oops, don't delete that. So what I do is I draw the 2 C's. So I've got 2 carbons and I draw them around where that double bond is. So the double bond's here, so I'm just going to draw those 2. I'm going to make sure it's not a big blobby like that. So let's see. And this time, we're going to break the single bond. I'm going to draw it a little bit longer than usual, just to kind of accentuate that. And then we've got these hydrogens around here. You can see over here, I've got hydrogen pointing up and another one pointing down. I'm going to draw those again, but I'm going to exaggerate it and point them directly up. So vertical, just like this. It makes it much easier to see and much easier to draw. Now, when that bond has broken, it's not just disappeared, but what it's done is it's formed another bond with the monomer next to it to the left. And then we also have the other one, the other monomer, that's formed a bond to its left. And it's just going to be that cycle near infinitely. The way we show that is that double bond breaks. So here's the double bond. We're going to break that. Oh my God, what have I done? Oh my God. Is it going to let me delete this? No, it's not. What have I done? So we're going to break that double bond by ruining my entire drawing. So break that double bond. That double bond's gone. And then we're going to extend the arms out and put brackets around it. Because this is a near infinite repeating unit, we don't know how many of these units are. We're just going to call it N. And that's the process. So really quickly, I'm going to do it one more time just so you can see this without it messing up for me. I'm going to have a C double bond C, and that's going to be my ethene. To show this as a monomer, what we're going to do is to draw the 2 C's adjacent to each other, just like this. We're going to break the double bond and make the long arms first. You can even do the brackets if you want now and call that an N. And then what we've got is a hydrogen pointing up, down, up, down. I'm going to draw that in here as well. So up, down, H, 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 and then all of those bonds. And that's how we do it. It's as simple as that. What I'd like to do is for the task below, you can see that I've already given you the outline of this. And again, we're looking at chloroethene. So I've given you the 2 carbons next to each other. I've already broken that bond for you, and then I've extended those arms out. Because it's going to be a polymer, we show that by doing the brackets. So you can see the brackets here. And we've got an N amount, which could be 3, 5, or 759 trillion. We're just going to do N. What I would like you guys to do is, can you complete the rest of the polymer by drawing these in the correct orientation? Although it's a single bond, it rotates. Just try and keep it similar. And then I would like you to do the same thing from scratch for this one. Remember, double bond breaks, arms go out, brackets on, give it an N. Pause the video, have a go at this. It shouldn't take you very long. All right. The next one we're looking at is esters. And if you're looking at this page for the first time, you might be thinking, oh my God, there's so much going on. And you're absolutely right. So what I would like to do to make your lives a little bit easier, again, I know it's in the booklet, so I'm not trying to hide anything. I was going to get rid of some of these additional repeating units. And let's get rid of these waters as well. And then to make your lives even clearer, let's get rid of this bit over here. So what I'm trying to show you here is what is the important part about a condensation polymerization. Right, now we've got some of the clear things on the screen, let me talk you through it. So a condensation, just like we did the condensations last time with the carboxylic acid and the alcohol, we're releasing water and forming a bond. This time, we're going to release water and form a bond, but we're going to do it on both sides of a molecule to two molecules to get a massive long chain. So if you think back to how we did it before, we've got a carboxylic acid, which is this C double bond O and then OH. And what we've done is we've stuck another one on the other side. Then we've got an alcohol. And then we thought, you know what, let's stick another alcohol on the other side so we can form a bond on both sides of it. Now, the trick to this, or any condensation, is by what I'm going to say is finding the water. Can you find the water molecule in the two that you're given? So we zoom in, you should be able to see two sets of water molecules, and I'm going to highlight them in different colors. The way that I like to do this that makes my life easier is I do the edges first, and then I do the inside afterwards. So the edge, I'm going to find a H2O. You can do this in two different ways, but I'm going to do it this way. So I'm going to add this hydrogen here, and then this OH. You can have it the other way around, and that's fine as well. Then I'm going to find the next set to complete that chain. I've got some of you might say, oh, I've got a H here, and then I've got an OH here. And in some instances, that will also work, but I like to keep them in pairs. So I've got an H here, so I'm going to do a OH here. I've got an OH here, so I'm going to do an H here. And that's just the method I use every single time. So I'm going to try and identify two waters. What's going to happen is the red ones are going to form a bond where the O is to that C, because the OH is going to go. So this guy's going to go, it's going to form a bond here like that. Then this one's going to form a bond, oh my God, I've lost the page. It's going to form a bond from this carbon, dot, 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 dot. Imagine it going over here, and oh my God, it's going to form a bond to that oxygen over there. So we're going to get one massive long cycle that looks a little bit like that. Now, I know I sound a little bit crazy saying this out loud, but it's as simple as that. So let me go through an actual example to show you how simple it can be once you've got the idea of it. The key points is that it's a repeating monomer, and they both come from the polymer comes from both monomers, and a water molecule is released as a byproduct. So you're always going to be releasing waters here. I'm just not going to show them every single time. What I've got for you here is a scaffolded version that I've already done. So you can see I've already broken it down here like that. I don't think that's that useful. I'm not going to try and hide this from you. So again, for those of you that are trying to pause the video and write the answer down now, that's fine. I'm going to take you through it anyway. I just want to show you how I would do this. So let me delete this now and let me take you through it. So again, before, what I said is I'm going to identify the waters on both sides. So I'm going to try and find the water. So I've got an H here, and I've done the OH on the other side, and then I found the ones in the middle. Now to do this, to draw this, I'm just going to draw it in one line, and everything that I've highlighted is going to be removed and become a bond instead. That's essentially how I'm going to do it. I'm going to start over here with this C, and then I'm going to finish over here, and I'll talk you through that process. I think once you've seen how I do it, it might make life easier for you, and let's get straight into it. So I'm going to start over here with this COO. Remember, I've lost that H. So I'm going to go C, double bond O. I'm going to do a single bond to an O here, and that blue bit is now becoming a long bond. Remember, it's going to be polymerized. This carbon is next to another carbon, which has two hydrogens, one going up and one going down, which is next to another carbon, which is next to a carbonyl, C double bond O. And that is bonded to an OH, which is in red, which means I've lost it, which means the next thing it's bonded to is the thing that's not highlighted, which is going to be that O over there. So I'm going to do this in red so you can see it. So I've got a single bond over there to that O, which I'll do in red, which is this O. And then that O is bonded to a C, hydrogen, hydrogen, another C, hydrogen, hydrogen, and then this is bonded to an OH, which is now gone. So there we go. We're going to do long blue arms just like that. And you can see it's the same thing as at the start of the video. And then what we're going to do is going to do brackets around this whole thing. And then we have an infinite or n amount of this. I'll put n there. And just because I get stressed otherwise, I'm going to go X H2O. So at least we know we've still got the waters in there. We've not lost them. I've not lost anything. I've not changed it. What I would like you to do now is, using these other two examples, can you have a go at polymerizing these using a condensation? I've identified the waters for you to make your life a little bit more easy, because I appreciate this is a bit weird to look at. We will have some more practice in class. And for those of you that have realized you do not have enough space here, so I would just do the answer here and probably here. And that's my fault, because I probably should have given you guys a bit more room. Okay. Once you've had a go at this, I'm going to move on to the next section, which is another condensation, but we're looking at something slightly different. Okay. So like I said, we're looking at, again, another condensation reaction, but this time we're doing something called polyamides. So we're going to form a polyamide, and what we're reacting with again is these H2Os. So you can see these waters, and we're going to do the exact same process as before. You're going to identify where the water is, and then you're going to draw the molecule as one in the brackets with the arm sticking out. Now, when you look at this, I think for the first time, it might be a bit overwhelming. I don't want to go through this one again because it's very similar to the one before, but what I will do is I'll take you through the first example, and then I'll let you guys have another go. So you can see here, I've got those formed right there. It says draw the structure of the polyesters formed below. And this is a type of question that you could be asked that could be up to 2 to 3 marks. What I've done is I've identified where the water is on the other side. So you can see in blue, I've got the OH because it's nice and clear. And then what I'm going to do is I'm going to steal one of those H's. When you see 2 of them, I'm going to steal one of them. And I'll show you how that works. And in the middle, I found another water. And as you can see, like last time, I've got the actual OH again. So that's fine. But I'm going to steal one of these H's. And for me, for amides, that works much more easier in my head, because I remember there's no oxygen on that side. So it has to come from there. Right. Let's start off from the left, and I'll give you an example. So I'm going to start over here. Remember the blue bit is gone, so I'm going to draw that as a simple line. That's connected to a carbon. This guy right here is a carbon. Shall we do it in skeletal? Yeah, let's do it in skeletal. So the blue one connected to a carbon. And let's do that as a carbon like that. Let's do it downwards. If you do it up or down, it doesn't matter too much. That's connected to another carbon. There, and there. So 3 carbons in a row. Let's draw this now. So I'm going to go 1, 2, and then 3. That third carbon is connected to a double bond O. So the double bond O pointing upwards this time. Which is then, oops, I didn't mean to delete that. Which is then connected to the OH. And remember, the OH I've highlighted, so I'm going to delete that, and I'm going to replace it with the next thing it can be bonded to. So you can see over here, I'm going to try and draw a line from over here. So I'm going from this carbon to this nitrogen. And that's where I'm going straight away now. So from this carbon to this nitrogen here. Remember, I've kicked off one of those H's, so I'm going to write the other H here. You can write it above, you can write it below, it's not too important. Then that is connected to 1, 2, 3, 4, 5, 6 carbon chain. Let's draw the 6 carbon chain first of all to make our lives easier. So I'm just going to go 1, 2, 3, 4, 5, and 6. At the end of that carbon chain, it is bonded to an N, which is bonded to an H, and then one of those H's have gone, so I'm going to draw that in blue, which is going off my screen, because I hadn't prepared for it to be that large. I probably should have drawn it smaller. Let's move it over here. Let's shrink him down. So you can see it's going to look a bit like this. Now let's fill in the branches. So I've got a branch on this carbon over here, so that's the second carbon. So branch there, and then I'm going to go 3, 4, 5, and there's a branch on 5. So I've got 1, 2, 3, 4, 5, and there's a branch right there, just like that. Now, around the blue bits, I'm going to put brackets, because it's going to be a monomer. And remember, I've got N amount, so I'm just going to put an N there. Now that I've gone through this example with you, I'm really glad that I took you through this one step by step, because I think there was quite a lot of things that was going on, but it's as simple as that. So identify the outer bits, identify the inner bits, anything you've highlighted becomes a new bond. And I think that's the trick that I'm going to teach you for it. Right, guys, have a go at this. And then I'm going to talk you briefly through the last page, where hopefully it'll be the last time you hear my voice in a video. So The last section. This is the very last section of the AAQ Unit 2, and for some reason it's got its own little portion, and I don't really get how many things they could ask you for this. So what we've done is we've compiled some of the most common things that you've been asked in previous exams, and I think this will be the most common thing that will come up. So these are for benefits and problems arising from combustion, haloalkanes, polymers, and alcohols. So any of the directions we've just covered, what are the problems, what are the solutions, what are the benefits, the pros, the cons, and so on. Now, there's hundreds and maybe even thousands of different benefits, problems, and solutions. But the most common ones are the ones I've identified in the table. These are the ones that we see most often at GCSE and A-level, so these are the ones I'm going to try and focus on. Now, I don't really want you to remember these off by heart. I think this is just a case where they will give you some information and you might have to identify or explain that problem. So you might need to understand a little bit about what this section is telling you. But at the moment, I just want to see if you can interpret the problem and then give me a solution using this multiple choice question here. Have a go at these multiple choices, and then when you finish that, pat yourself on the back and you've done it. You've completed all of the Unit 2 chemistry, and now it's time for us to revise. You've done incredibly well if you got this far. Really well done. Hopefully you've not gotten too bored of my voice, and if you do need anything else, please just feel free to reach out. Thank you for all your time, and I won't see you in the next video, but I will see you soon. Thank you.